right? Okay, the recording is on. So we will go back to the lecture. We were discussing about the traverse sheet. Right, we were discussing about the traverse calculation. I'm not going to explain about the traverse and everything. So we were discussing about the traverse sheet, right? And in the traverse sheet also, I asked you to complete up to the whole circle bearing, and the length column was there. It is the row data and delta E, delta N. So this is where we stopped in the last session, right? In each row, right? So we know that we have the lines coming in row by row. Let's say AB, then BC, CD, etc. Right? The rows of the lines. So they are in each alternative row, and up to now what you have, the length as a row data for each one. It is a line property. So you have length AB, BC, CD entered as a field measurement, and the first whole circle bearing is a field measurement, and the remainings are calculated one. I ask you to calculate all these bearings, and also right. So one student has asked about the weekend, right? I don't have any lecture in the weekend, but if you have the scheduled lectures, it would be conducted, right? As lecturers, we were asked to continue without wasting your time, right? Especially for your senior batch, because we want to send them to the for the industrial training. So we were asked to complete it before July 5th, right? So their lectures would be for them. Actually, we are conducting extra lectures also, right? For your one, I think no extra lectures would be scheduled for this week, but week after, then thereafter it will be like that, right? Only tomorrow, the Vesak public holidays would be extended, right? Okay, so and the last one I told there is a check, because at the bottom you have to have the same line which you started, and there should be a bearing, whole circle bearing, as same as the calculated one. They two should be same. And thereafter, I ask you to calculate delta E and delta N, because for each line, now you know bearing and length. Length and bearing are known. So we know delta E is always L sine phi. So you have to record with the sign. It is L sine phi. I told you the importance of these two parameters and how to remember them if you have any doubt, right? Delta N is L into cos phi. Right? So whole circle bearing is phi, and length is there. Then you have to, so it is a calculated one. So you are asked to enter the first for AB. I asked you to select the last one. Then you have to enter all these delta E and delta N. So I gave that part as the homework, and Today, I am supposed to continue from there, right? So these are the results which you are supposed to have, right? If you have calculated, please check with these numbers, right? For the time being, you forget about this, the bottom line. Right? So please check with this one. I need you to check with these numbers and these numbers. Right? So they are calculated bearing values, and the bottom one I have checked. I have put it in red because I told those are the checkpoints. It is very essential to have 45, 20, 20 because that is the field measurement, which is in blue color, right? Which is in blue color at the top. And then you are supposed to calculate the delta E and delta N values, right? You remember, you check with the sign also, right? The first one, the bearing is 312. 312 means that is in the fourth quadrant, moving towards northwestern direction, right? 312 means passing 270. 270 means the west direction, right? The west direction is 270. Then above that one, that is towards the northwestern, then E should be negative and N should be positive. So you don't have to check, right? Because your calculator will give you these signs correctly, but you can double check, right? The second line, CD, the bearing is 218. 218 means pass in the south direction, so in between south and west, right? When you turn from the north, 180 means southern direction. So passing southern, that is a southwest direction. So both your delta E and delta N should be negative. Third one, 119, right? So that is passing 90. So you are moving towards a southeast direction. You have passed east direction, 90 is east direction. So passing east, another 29 degrees and something. So E should be positive and N should be negative, correct? And 45, that is a small angle, they are both positive, right? If it is exact 45, 0, then delta E and delta N would be same, right? Because this is simply passing 25, 45, then delta E would be little bit higher, but they are, you can see both are 32 point something. So only the decimal part is varying, right? Anybody have question with this? So this is a time for you to raise questions. If you have done this calculation by your own, and if you have any question, maybe calculation, maybe problem with the calculator, right? If you don't get these numbers with your calculator, still you can raise at this point. Do everybody have these values, or is there anybody having different values, right? So please ask, and if you have calculated, please check them. If not, please note them, and then you can try with your own. This is very important one, I told, right? Travis one, it is a part of your field work. For your field work also, you are supposed to calculate this type of cover sheet with your own measurement, and you can expect a similar question in the final examination also, right? And when you go for industrial training also, this surveying part would be very important. Remember, there is no difference in surveying with the level of engineers also. This is actually the level of engineering curriculum also, right? There is no any middle level separation for surveying. I teach you and I'm supposed to conduct the course content. It is up to the level of engineers, right? So during our last accreditation visits, right, the external examiner asked what is the separation between engineering and technology degrees, because the curriculum, the titles are also same, right? For example, when we consider structural design, they ask what is the separation, what is the difference between engineering degree and technology degree. So then we told that, so this is the separation. Engineers, they do the designs up to this level. So in our case, we are teaching up to this. Likewise, but for the surveying, they also agreed, right? So we don't have any separation because there's no any middle level. You are supposed to do a survey and a setting out by your own, right? Okay, so that is the importance. So you can, with this one, with this knowledge, even you can, if you practice these ones, you may conduct a survey also by your own. I will show the real examples, right? The real examples, these calculations were used, where we have to use, right? So that is the maximum. Okay, any question? Any question? Anybody having a different angle or any problem to gain these numbers, which I highlighted in yellow?
Excuse me, sir.
Yes.
When we are doing the calculating, as example, delta E, we should firstly we should do 59.330 shouldn't multiply by sine
312.
312. How
Degrees.
to,
Yes.
yeah, how to degree separately degree second and in the calculator?
Yeah, I explained this one in the last class also. Right, when you use your calculator, it is very important. I always recommend you to have the calculator and do the calculation. Right, so what you have to type in your display, right? So you have to type whatever the distance, right? Let's say 59.335, or sorry if they are different, right? Then actually the bracket is not necessary also. You can type sine 3, that means 312 degrees. For the degree sign, you have to press the button. There's a button having degree, minute and seconds in the same button. In the same button. So what you have to do is you press 3, 1, 2 and that button. For the first press, it take the quantity as a degree. Then you put 8 minute. For the 8 minute, again you have to put type 8 and then again that button. For the second press, it will take that quantity as minutes, and then let's say 20 seconds, then 2, 0 and again that button, then press enter. Minutes and seconds. So this is how you have to press the angle, right? 3, 1, 2, then that degree, minute, second, degree, minutes and second button. right? So we call DMS button, degree, minute and second, then 8 and the same button, then 20 and the same button. If you want to press minutes and second only for any angle, sine, cos, tan or any, then first you have to press 0 degrees, right? In the display, you don't see these signs, so you will see only a comma, right? In some displays, it would be displayed. It would be displayed, right? Okay. So this is how if you use a bracket, even it is okay. You can use a bracket, but it is not necessary, right? It is not necessary to open a bracket and close the bracket, but if you open, you have to close it, right? Without a bracket also, it will work. Even here, you can press multiply. It is also not necessary, right? O bracket, it doesn't matter. And the multiplication not necessary. If you need, you can put this one, or you can open a bracket over there also, right? But when you put sign, automatically in some calculators, the bracket would be open, right? Bracket would be open. Then you can type the angle and close. And at the same time, there's another point. Please make sure in your display, right? In your display, there is a small letter D and R on the top, right? Above this sign, you have different numbers, and there is a small letter D and R, right? That means the mode of the angle or the units of the angle. This D, if only one would be highlighted or active, right? So D refers to degrees and R refers to radian. R refers to radian because we know angle can be measured either in degrees or radian, right? While you are typing this way, your degree mode should be active. It should be in degree mode. If R is highlighted, if R is active, then you don't get the correct angle, because then even though you type degrees and degrees, minutes and whatever, the calculator will take the angle in radians, right? In radians. So you have to change the units with the mode button, right? When you press the mode, it will be degree radian, and you can select, right? You have to select. You must select the degree mode, and your calculator should be in degree mode, right? If it is in radian mode, for example, now we know cos 60, right? Cos 60, we know it is half or 0.5, right? If your calculator is in radian mode, when you type cos 60, it is not equal to 0.5, because even though you type cos 60 degrees, right? The calculator will calculate for 60 radians. 60 radian, I think you may know what is 1 radian, and right? Then you have to change your calculator into degree mode. If it is in radian mode also, you will not get the expected answer. Even though you type degree, minute and second, it will take the value in radians. Okay. Is it clear?
Yes, sir. Okay.
Any other question? You type this and your calculator will give you a value with the sign, right? And the next what you can do is you can go there and just change the sign into cos, right? You can just, because length and angle are same, so you can just change your sign into cos and take the delta n also. And do that for all the lines. Never mind how many lines you have. If you are moving in sequence, going in the round in order, right? You will get all these delta E and delta N by simply by these two equations, L sin phi and L cos phi. Right? Any other? Anybody calculated and end up with these values? Do anybody get the values? I want to get it confirmed. Right? Okay, so that is the next procedure. The step calculating delta E and delta N. Still, don't worry about the bottom values, the minus 0, 1 and 0.4. I didn't explain up to that. Right? Just calculate these ones, the highlighted ones, using L sin phi, L cos phi. L is the length you got it as a field measurement, and the other parts, bearings, are calculated using the first bearing measurement and the corrected angles. Angles should be corrected. Right? So we are using corrected angle, and I explained the process of calculating the bearing. Right? That is in the traverse sheet. Right? You have the bearing. Right? Next to that, you have the corrected angle. So you have the values entered in this order. You have A here, B here, C here, D here, E, F, like this. Sorry, these ones need to be calculated. So these are the measurements. Observe, so the corrected angles are there. At each alternative row, because we leave one row for the bearing, and these are the things you have to calculate. And for the calculation, we calculate this one as A plus B, then plus or minus 180. I told you how to select the correct sign. Right? You first add A and B, right? And calculate. So if I take this as X, the final value, then the next one is X plus C. So this is X plus C plus or minus 180. So I take that value as Y, final value, then Y plus D. I explain how it comes. If you have any question, you can ask later, because this is something I explained in the previous session. So we normally say the process is something like this. Then this one and this one comes there. This one and this one comes there. Likewise, without looking at a sketch, you can calculate all the bearings if you have correctly entered that in the traverse sheet. So that is the importance of using a traverse sheet. If you have 100 number of stations, you don't have to look at a sketch and calculate. If you correctly entered in the correct direction, you can keep on calculating, or you can use an Excel sheet like what I have done, right? In practical cases, but in this curriculum, you are supposed to do the calculation manually, and during the field class also, you are supposed to do it with manually, right? Okay, so that's what you have by now. You should have by now. I don't know whether you have these numbers, but we are going to proceed from there. Okay. Then the next step, right? So I have explained up to step 5. Calculate delta E and delta N of all the lines, right? Then we come to next step, step 6. Calculate corrected delta E and delta N. Why you need to calculate the corrected? That means what you have calculated by now are not correct. Are they not correct? Because we have used the corrected angles, right? So we can think about, okay, these angles are okay, but there can be some errors in the lengths also. For example, this 59.330. In the real one, it can be 60.330, but you wrongly measured it. Then what will happen? Your delta E and delta N would be wrong, because you have used an incorrect length, but we don't know. So whatever the values, you can get a number. For example, if I use 100 here, still I get some numbers, right? But I don't know whether it is correct or not. Then what I do? I want to correct them. For the correction, first I should know whether it is incorrect. If it is incorrect, then only I can correct it. So you have to identify the error. To identify the error, you should know the correct value. If you have something in your hand, right? It can be, let's say, for example, you got some amount of money, right? Somebody gave you some amount of money to your hand and left, right? Let's say you want to check whether you have received the correct amount. Then you have to check from where the source of income and check whether how much of money you should receive. Then only you can compare whether you have received, or if you have the receipt and the money, then you can check with the receipt. Okay, this much of money should be in your hand. Likewise, if you want to correct it, or if you want to realize whether it is correct or not, you should know the correct amount or the actual amount. In this case, we don't know whether this 59.33 is the correct, because you cannot go to the field and check it again. Any length, now you cannot check, right? So what we can do, we add these delta E's and delta N's separately and get these two values. This hatched one in the blue color, that is the vertical summation. You sum up all delta E's and delta N's for what? If you add these ones, you get minus 1 millimeter, minus 001 means minus 1 millimeter, and delta N plus 4 millimeter. What is the meaning of that? You can add it, but you should know the meaning. Why you are adding? Why you are adding? Right? The meaning is this. If you move along a closed polygon, you have started from there, move along a closed polygon, right? Go somewhere and come back to the same position, right? Whether it is 3 node, 4 node, 5 nodes, 100 node, You have come back to the same position. Right? Then what is your net displacement? It should be 0 because you have come back to the same position. Right? Then if I just check what is the net displacement in each line. Let's say when you take the first line, I am taking only in the east direction. It is this much. For the second one, let's say it is right to the east direction. So, sorry, north direction, then no displacement in the east-west line. From the second one, you have a minus displacement of this much. For the next line, displacement negative this much. Likewise, you have a movement and you section it, you divide it into east-west displacement and north-south displacement. Then what is the summation? For example, I take a very simple one. I take a triangle. So this is my movement. I start from A. I move to B, from B to C, sorry, C is here, and C to D. For the first line, what is my displacement in east direction? Let's say this amount. I take that as X. For the second one, I take the displacement, I complete a right triangle, and this is the amount. It is in the negative direction, but I take that amount as Y. I know this Y is a negative number because it is moving opposite to the east. And the third one, it is Z. If I come back to the same position, then I know X plus Y and Z are negative numbers. That is that, but that amount is inside the Y. For example, Y can be minus 11.5. Z can be minus 6 point something. X should be a positive number. Right? But if you come back to the same position, I know X, Y, Z should be 0. If you come back to the same position, your net displacement in any direction, it can be east-west, it can be north-south, or any other inclined direction, right? The projections should be 0, right? So this east-west direction is delta E. So what we do, we know if you travel along a closed polygon, right? When you sum up all delta E's and delta N's separately, right, along the circle perimeter. So you have to go in the correct order. If I take CB, then it will not be 0. Right? If I take CB direction, CB line, delta E of CB, it won't happen because then Y is the positive number. So then XY Z is not 0. Right? If you go in a circle, because here we have marked all the lines in an order. In your travel sheet, you start with AB, BC, CD, likewise. Right? Come back to B. Then the summation should be 0. We know we have moved along a closed polygon, and we know if you sum up, it should be 0. But when you add, it won't be 0. So 0 is the expected value, or we call the actual value. If you have perfect set of measurements. If you have perfect set of measurements, then we know it should be 0. When you add your angles, it should be 360. If your all angles are perfect. Then in our case, it was not 360 because they contain some errors. They contain some errors. Because of that, it was not 360. In here also, now you add all delta is and you expect 0, but it is not 0. Then that is the error. Error means measured minus actual. Your actual value is 0. Right? Actual value is 0. Then what you have in your hand is the error. Right? You do some work without expecting any money. Right? So let's say you do a voluntary work. Then at the end, somebody come and give you some money. So we know that person is mistaken. Because you are not supposed to have any money for that particular work. So then if you get it, you know that you were given by mistake. Right? Somebody did it wrongly, then you have something. So the entire amount you got is the error. So you have to return it. Return entire amount because you expected 0. If you are genuine. If you are genuine, then you have to return everything. Say that I didn't expect. So this is the error. Right? If you expected 100 and if you get 150, then 50 excess is the error. You agreed for 100 and at the end you get 150. Right? Then you have to return only the additional 50. That is 150 minus 100. 100 is the actual or the expected. Right? Here, expected amount is 0 because we moved along a closed polygon and we finish at the same point. So your net displacement should be 0. Right? So if you conduct the graphical method for this case, then we can have some idea. Let's say we start with A, B, C, D and A. Now you will get an idea where you will stop. In this case, you end up with -1. That means 1 millimeter in the west direction. So in this case, if I draw a little bit, and if you do the graphical method for this, right? You start with A and continue with observed distances and corrected angles. Then where you will stop? Your A dash would be finished 1 millimeter this way and 4 millimeter in north. So this is 4 millimeter. So you will end up with this way. So your A dash will come somewhere here. At the end, you have 1 millimeter minus 1 millimeter displacement in east. Minus means you are in the west direction. Right? So you are in 1 millimeter to the west and 4 millimeters to the north. So if you plot these measurements in a graph sheet with the correct angles and lengths, you will end up with like this. 1 millimeter to the left and 4 millimeters to the north if you maintain north in the vertical upward. If your north is vertical up, you will end up with a graph like this. So that is linear miscloser. Why we call it linear miscloser? For this delta E and delta N, for both these delta E's and delta N's, L and phi were involved. So you calculated it using L and phi. L sin phi, L cos phi. So you use two parameters. Then any error would be due to both. There can be errors in L, there can be errors in phi. But by this time, these bearings, angles are corrected, therefore these bearings are correct. So you can believe that your bearings are okay, so they are corrected. Therefore, if you have any error, that is purely due to length measurements. So this error, you can say this error is 100% due to the errors of lengths. So you can claim on lengths. You can complain, right? There was a noise in the classroom. Girls and boys are there. But if you know all the girls are silent or something out, then you can complain that noise is purely due to boys. Right? Likewise, here also, there are two parameters involved in calculating delta E and delta N, but phi values are corrected. Therefore, this is due to the length errors in the lens. So we call this amount as linear miscloser. So Li, this is called the linear miscloser. Linear means length measurement. Linear measurement means in surveying we call length or straight. Right? So this is linear miscloser. It is not closing because of the errors of the lengths or linear measurements. So we name it as linear miscloser. In the previous case, the misclosing of the angles we called angle miscloser. This is called the linear miscloser, right? If you plot it, the final imbalance, because you expect this A dash will come right on A, but it stops somewhere away from A. So that distance is called the linear miscloser. So how you can calculate this linear miscloser? Right? How you can calculate for this case? It is 1 millimeter horizontal and 4 millimeter up vertical. And we know the miscloser means this distance, the diagonal distance. How you can calculate this is one by using the Pythagoras theorem, 1 square plus 4 square to the square root. So this is the linear miscloser of your survey, of your measurements. Right? The linear miscloser of your set of angles and lengths is this much. Square root of 17, that is 4 point something millimeters. If you calculate, this is square root of 17. That is 4.01 something. In millimeters. In millimeters. If we generate a general equation for this linear miscloser, what you can say? This 1 is the summation of delta E, 4 is summation of delta N. Therefore, I write a general equation for linear miscloser, right? I can write a general equation. Linear Miscloser of a survey is equal to square root of sigma delta E, that is summation of delta E's to the square plus sigma delta N. We know that is the vertical component. We have to take the square, but we are using the Pythagoras theorem. So this is the general equation of linear Miscloser. Hope it is clear, right? So I explained it with these numbers and then substituted the meanings of each number. So 1 is 1 millimeter is the horizontal component, that is delta sigma delta E, right? Sigma delta E and sigma delta N. From that, sorry, this should be Miscloser, CLO. Sorry for that mistake. This Miscloser, CLOSOUR, SURE, closure. Linear Miscloser, the general equation is, so that quantity is very important. I will come to that later, right? So we can calculate delta E and delta N, the summation. The summations give us a meaning, that is the total error in east-west direction and the displacement in north-south direction. We don't expect any final displacement as we stop from the same point we started. We expect 0. So what you get is the error, right? What you get the error in each direction, the horizontal way and the vertical way displacement. Then the total displacement or total error can be calculated by applying the Pythagoras theorem. Okay. So we come to our sheet again. What we do, we calculate the summation of delta E and delta N. Don't take this delta E, delta N for AB line. Don't put two values, then it will not be 0. So you have to have the entries equal to the number of lines. Remember, you have AB in AB twice. So I don't enter the delta E, delta N in the first row. I enter them in last row. I will explain why. Right? Now you found out the error. If you know the error, you can correct it. Before correcting, you should know that there is an error. If you believe that you are correct, then you will not be changed. If you think that you have done the correct thing, if you realize, then only you can correct it. Right? To correct the error, first you have to identify the error. Now the error is identified, then the correction is the negative of that one. Correction is the negative of the error. So if you have 1 millimeter less, you have to add 1 millimeter to the sum in order to make it 0. For the delta N values, you have 4 millimeter excess. You have additional 4. That additional should be reduced. So the correction is -4. Right? If you end up with below the expected value, you have to increase it as the correction. If you are above the expected, you have to reduce it. You have to lower the values. Now, how we can distribute? So this is actually where, even though we name this method as Bordich method. Bordich method, it is there in the lecture note, and curriculum also, right? The Bordich method. The Bordich method comes at this stage, right? To distribute this error, there are different theories. Different people have introduced different techniques, right? The most recommended method is the Bordich method. The Bordich says to distribute that, definitely we have to use which basis. Now, last time I explained two bases: to distribute something or to collect something. To collect something or to distribute something, we have two bases. One is the equal basis, the other one is proportional basis. If you consider the size of the member, it is proportional, having smaller share for the smaller people and larger shares for larger members. So if you don't consider the size, it is equal basis. I explained explained it with examples also about how you use these things in your day-to-day life. You are using it without noticing. You don't notice, but you are using it. You may have the cost shared equally, and sometimes you use the proportional. In this case, these are lengths. I told now this error is purely due to the length. For the length, we normally assume when you measure shorter distance, you create smaller error. When you measure larger distance, large errors are. Therefore, you have to use proportional basis. You have to use the proportional basis. So what we use, right? We take the summation of all the lengths. We assume that you create this 1 millimeter error when you are measuring this total length. So I take the sigma L also. I take the total length. I add all these lengths and take this value, right? And what I do, I assume I measure all these lengths L1, L2, L3, etc. And when you measure this entire length, that is total length is sigma L. So you create some error while you are measuring sigma L, and what is the share for L1, what is the share for L2, etc. Then the correction for first length is error, or let's say minus error, divided by sigma L multiplied by L1. If you have the error 1 millimeter, right, then you can directly calculate the correction. Correction is negative times the error. So for the first case, you want to add 1 millimeter. That 1 millimeter should be shared among 4 members on their based or proportional to their lengths, right? So here actually then these shares will come very low as the error is 1 millimeter. But definitely when you do your survey, this it will not be 1 millimeter. So you may have some considerable amount of error, right? Then we can display it, right? So is this calculation is clear? So what we do in this case for length AB, if you want to calculate the correction for AB, right? Total correction is 1 millimeter plus 1 millimeter divide by 217 point something multiplied by that particular length of AB. Right? Length of AB, you can put it there and calculate. Similarly, you can calculate for BC. Right? You can very simply use your calculator, change the value and calculate. And the usual practice is we put that correction in this cell. The correction of BC, right? If you calculate, it should be this much. So we put it over there. Actually, it comes as 0.24 millimeters. 0.24 millimeters. We put it just below the delta E value. Right? Similarly, we have to put all these. If you just see the formula I have used, right? So if you can see the cell address, right? To calculate this minus, right? The value I have used, now you can see, right? M16 is the total delta E, sigma delta E divided by L16. L16 is the total length and multiplied by respective length 59.33. Sorry, my connection was dropped. I don't know from which point it was dropped, right? I realized it later. So what I was explaining is this part. I think you heard that part. How to calculate this correction, right? For that, I used this worksheet and I was showing the address, right? The equation I have used. Right? M16 is the sigma delta E. So I divided that with the sigma L and multiplied by the respective length L7. Right? Then I have these numbers, right? 0.24. So these are the negative of these ones are the corrections, right? So you can use it up to 1 decimal. right? So these are the corrections, but we have to use the uh, minus of that. So in this case, we can use plus. This should be minus. And using up to 1 is enough, or 4 decimals is enough. So I can take minus. This one is 24. That's enough. Moving up to that is enough. It should be again minus, then 0. We can mark it as 24. Is this calculation clear? It should be minus. And we can make it for 4 decimals. Let's say 1, 1. Is this calculation is clear the way I calculated? So what I want to do, and I use the proportional distribution. If I have 1 millimeter, it should be distributed proportional to the lengths. Now these lengths are almost in the same order. You can see 59, 57, 54 and 45. So their order is very equal. In some surveys, you may find that there are very long lengths and very short lengths. Then there would be a remarkable difference between these corrections. Right? So what we have to do is we have to distribute, and the usual practice is to put them below the, say I make it I mark it for 2 decimals. This should be minus. And for 5 figures can be a 099. I can make it 19. And this one is minus. Then if I take the summation, this point it is 0.03. Then I want to balance. I want to balance this summation. Then you can see if when I calculate, there is a 0.11 error. So I can make this 3322. Right? I make this one 0.03. As I have all my coordinates up to 1 millimeter, then going up to 4 decimal is enough. Right? There also I can make it to 4 decimals. When I make it for 4 decimals, this is 1. This is also 1. 99 is again. Right? So the 4 would be equally distributed as these lengths are almost same. Right? So here also there is a you have to fill these corrections or errors usually in a bracket. So you have to put this in a bracket. I don't use a bracket here because I want to add them. And then you can put the corrected delta I delta n, that is equal to the measured one plus the correction. If I add these corrections also, if I use the so this is, so these are my corrections. And I can add them. So this is how I want to do the correction for delta E and delta N. What I did, I distributed this error proportional to the lengths, and those values are shown the cell below the row values, and that correction is added. Right? So this should be plus. Now you can see actually this blue color one error was now changed. It was changed because I had originally it was minus 0.001. I leave those values. Now if I add these ones, the summation is 0. And this is also a checkpoint. After you correct your delta I and delta n, it should give you a sum of 0. The summation should be 0 for the corrected delta I and delta n's. Otherwise, your correction is useless. Right? The meaning of the correction means getting it to the 0 value. Right? So these are the corrected delta E and delta N's, which is the step 6. Step 6 in our procedure is to calculate corrected delta E and delta N's. Is this step okay? So what you have to do is distribute the error. First you take the this blue color one, that is the linear miscloser, right? And it is not the exact linear miscloser, it is the linear miscloser in east, west and north, south directions separately. When you take them separately, these are the errors, then you distributed them proportional to the length. So that is the summary, and which are shown in white color are the corrections for each leg. Then you add these corrections and correct delta E and delta N. Finally, you end up with 0. And here you can see when you add those, it will be 0. Is it clear? So any question for this step? Any question? How you corrected, how you convert this minus 43.988 into 43.987? There was a addition of 1 millimeter, that 1 millimeter comes from the correction. If you go for 4 decimals, it would be different. So no need to go for 4 decimals. So I did it for 3 decimals. Okay. In this case, if you calculate for 3 decimals, you will never correct this 1. So I have reduced that 1 from the first one because that is the largest one. If you have a large error, then you have significant amount of corrections. For example, in this case, if you have, let's say, a 20 millimeter error, right? If this is 20, then you will have some larger corrections. In this case, actually, it is just 1 millimeter. Then you cannot distribute it proportionally to the accuracy of third decimal. If you go for smaller decimals, but it is not necessary. As we have measured all the lengths up to 1 millimeter, corrections are also up to 1 millimeter is enough. Right? Then we go for the last column. Is it clear up to this? Any question? The errors were distributed proportional to the lengths. Right? Error is the summation because we expect 0. Okay, for the last case, it is the coordinate. Remember, coordinate is a property of a station. Right? Coordinate, because for the line, you cannot have a coordinate. The coordinate is varying along the line. Right? Then what we have to do, we start with the first station. Now in our traverse sheet, the first station is B. Here if it is not given, right? If a GNSS coordinate of one station is not given, then you are free to select any random coordinate. So we go for local coordinate. It doesn't matter. It doesn't matter. So let's say we go for 500, 500. If you wish, you can use any other number also. Right? I use 500. Yeah, 500 up to 1 millimeter accuracy. You can use any, right? Thereafter, what we have to do? Now remember, you are in a particular station, let's say B, and the next line is there, BC. For the BC, you know corrected delta E and delta N of the next line. Corrected delta E is this, delta N is this. In order to find C, now you can see how we use the coordinates and bearings theory or knowledge. Now the B coordinate is known, then what you have to do? You have to add this X for X coordinate and Y for Y coordinate. So let's say delta X and delta Y. If you know A comma B, for the second time also it was dropped. Oh, okay, we continue, right? What I was explaining is you are in a particular position B, it is from B to C, and the corrected delta E and delta N's are known. Then in order to find coordinates of C, let's say if your axis system is like this, so the B coordinate is this. So this is E coordinate of B. This is E coordinate of C. This is N coordinate of B, N coordinate of C. Then, so this value is known, this value is known. Let's say 500, 500, and the corrected delta E is known. So this amount is known with a sign. If it is moving left to the right of you, it is positive. It is going left, it is negative. The value is there. So what you have to do, EC is EB plus delta E. So these sense have been taught before, right? So that's why I explained it separately. Otherwise, I have to explain in all the places, right? Now come back to the traverse sheet. So what you have to do, B coordinate. So the next line is BC. So you add this delta, corrected delta E to E coordinate and N to the N coordinate. And you can get the coordinates of C. Remember where I enter. I enter it in this row. The coordinates are entered in a row of a station. Right? This is equal to N coordinate, sorry, E coordinate plus corrected delta E. And you do the same, right? So 39 plus. So when you reach C, along BC, N coordinate is increasing by 39.813. So the coordinate would be 539.813. If you continue like this, hope it will be clear. Now you are in C. You are wishing to move along CD, then take the